ask you before I left a while ago. Over here, have we come to any kind of decision on the difference between these two?
We decided that, like, if it's with the x, like, you have a positive x, but if it's with the x, it'll change the x's to the negative, so that's why we flip over the y-axis.
Okay, interesting. Now, aren't both of these with the x? What do you mean when you say with the x?
In the parentheses. Oh, yeah, because like, when you distribute this one right here, it would be a negative x.
Would you mind, Gus, would you mind writing underneath there while she's describing when you said distribute it? Show me what that would look like. Right, so write down our expression there so we can see the difference between the two. All right, so we got negative x plus 5. Now, does that remain in the parentheses?
Yes.
Okay, so just rewrite the whole problem, basically, the whole function.
I'm moving everything.
It's all right.
I'm OCD, no, it's not.
Okay, so back to what you were saying. Now say it once more, but this time I want you showing me which one you're talking about when you said, like, explain to me, pretend I'm a Math 2 student. Okay, so I have a little knowledge of x, y axis. I understand there are transformations, and I've got a basic foundation, but not at the level that y'all are at right now. So talk to me like I'm a Math 2 student. Let me see if I understand what you're saying.
Okay, in this one, this was reflected across over the y-axis because it's with the x. So, like, if it was just plain x, it would be normal. But since it's negative, you move over to the negative side. Okay, that was that explanation.
See, this one is with the x before.
And y'all feel free to help her, okay? So, because I know y'all came up with this together. So.
See, this one is with the x before it reaches the exponent, and this one is with the x after it reaches the exponent. So, if it gets to the x before it reaches the exponent, it would flip over the y-axis. But since it's after it reaches the exponent, and you already have a number coming from that, it would flip over the x-axis.
All right, interesting. And I do think a Math 2 student would understand that. But here's what I want you to do. Let's back up to an 8th grade student.
Yeah, I'm not good.
All right, so let's think of something. What would be a concrete way that you could prove to them that, for example, if you just took off the bottom part of our puzzle, the vocabulary, the transformation, the rule, and we just focus on this, how could you prove to them that what you're saying is correct? Because you know.
How to prove it to them would be just plugging in numbers, would be plugging in and letting them see that it actually does.
Or you could show them this one, because this one's a little bit harder, because this one you're reflecting over the x-axis, and so, like, you can visually see that it flipped over. So it would be easier to explain with this one.
Right. Okay, so let me back up to what Gus said, and let's piggyback on this. So Gus said plug in numbers. Will it work if I plug the same x into both of these? Have y'all checked that yet?
If you plugged, like, the same x, but it wouldn't be the same y, but it would be like you would have a number on there.
Okay, here's what I want y'all to do, and I'll be back. I want y'all, before you start gluing anything down, I want you to do just that for me. Pick a few, and actually you can write them actually on here, so that if that student were sitting here, they've got a concrete example. Okay? All right. How's it going?
It's going good.
Oh, it is going good.
We really have
Oh, sorry.
5 or 6.
All right, I want you to explain to me. I'm just picking a random one here. I want to see what your thought process has been. Okay, so Logan, tell me when you were working on these, how did you begin? Did you start with the function? Did you start with the graph? Or did you start with the transformation?
We started with the function.
Okay. And then how did you go from there?
So we said that the negative right there is inside the parentheses, so we said that's why it's reflected over the y-axis. And then that means, I think, when that x was negative, it would stay like -4, which means it would go left. I mean, no, it would go right. I mean, I think, yeah. But we knew this right here was down 3.
Okay.
Then, yeah.
All right, so right now, let me clarify what I think I heard you say. So did you say it's going to reflect over the y-axis?
Yeah.
And it's going, which way did you say, right?
I think it's going right.
Right 4, and it's going down 3.
Yeah.
Maddie, do you agree with all of that?
I do.
Okay, what if I argued and said to you, wait a minute, this looks like it's going left for?
Well, there's the negative sign right there, and since there's parentheses next to it, it changes that so it goes right for.
Okay, so let's pick a point and let's see if that's correct. Okay, let's just verify. So what if we plug in, and you can write on here if you want to. So pick any value you want to, just to verify. Let's pick 3.
3.
Plug in 3 and see what's happening here.
So you plug it in for the x, right?
Mm-hmm.
3 minus 4 is 3.
Okay, so let's see if we're correct. You double check our work.
So that changes that to a pi 1 cubed minus. Yeah.
Yes.
And 1 cubed is still 1.
1.
And you minus 3, and that equals
Yeah,
negative.
Okay, so what did that -2 just tell me? What is the -2?
If you plugged in for x, would it be the x value?
Well, did you plug it in? Okay, you said you plugged in what for x?
Negative 1.
All right, so let's go back right here, and let's plug in. I think you plugged 3 in, didn't you?
3 in, yeah.
So f of 3 was equal to what you set up. So in the beginning, doing that might have been a good strategy to help you follow through. So you claim that your x is 3. So what does the -2 represent?
Your y.
So let's write our ordered pair here.
X.
So 3, -2. So let's see if you have a point 3, -2 on our graph. It's kind of hard to see because they're small.
1.
Okay, so you have, it falls on there.
Yes.
Okay, so is that enough to say, yes, I'm right?
No. So you need to find at least 2 other points to make 3 points.
It would be a good strategy, okay? It would be a good strategy. And as you're working here, I heard some of your conversations earlier about the placement of the negative. And that seemed to be something that you were, getting better and better at as you were going. But just remember, you always have that as a verification proof, okay? So if there are any of these, when you get ready to glue yours down, if there are any that you're like, wait a minute, before I glue it, I want to double check. Just remember you can do that, okay? Did any of them give you a really hard time, or you feel pretty okay? Feel pretty confident with
I
them?
feel pretty confident with them.
Okay. So when y'all are ready, you can grab your paper and start gluing them down, okay? And make sure, where's your record sheet? All right, make sure you record yours down. Oh, good, you already have. Okay, so the ones you're missing, you can fill those in. Okay, great job. All right, Trenton, how y'all doing over here?
I think we're doing pretty good.
Okay, Brandy, what you thinking on? You look like you're pretty in-depth thinking there.
I was just thinking which function is this. If this is x cubed or x squared.
Oh, this one?
Yeah.
Okay, so let's think about the parent function. What does the parent function of each of those look like?
Parabola.
Is which one?
X squared.
Okay, so would this resemble, is that a parabola?
Yes.
Okay, so does that help? Lay the two down that you were going between at first, and let's talk for just a second.
Like that, but those are both over the y-axis.
Trenton, as she's looking at this, she told me that she was having a question here. Well, tell Trenton what your question was.
If this parabola was x cubed or x squared.
Do you have any suggestions?
I think square.
Why?
Because I think because it's going down or up too. Well, no, that's
What's our parent function on this graph? What would it have to be, the parent?
x squared.
Okay. How would the graph of a parent function of x squared differ than the graph of a parent function of x cubed? Let me get the timer. I'm going to give you a few more minutes, guys.
I think it would go up further.